Hello everyone, I am Swati, working as Assistant Professor in Artificial Intelligence and Data Science Department of Annamacharya University. Today I am going to discuss about acid properties of a transaction in DBMS. So first let us know what is a transaction. A transaction is set of instructions that are carried out to alter the data in a database. There are various states that a transaction goes through over its existence. Understanding the transaction states in database management system is crucial for maintaining data integrity and consistency in modern databases. Database transaction is nothing but a logical unit of work that comprises one or more SQL statements. It ensures that a series of related operations either success as a whole or fail as a whole to maintain the integrity and consistency of the data in a database. Now, what are the operations that can be performed in a transaction? As we have discussed, a transaction is a set of steps to handle different circumstances, including even the system failure. So generally we perform two operations in a transaction. One is read operation, another one is write operation. The read operation means that reading the information or extracting the information from the database. Coming to write operation, it means that modifying the data or value in the database or adding an extra value, new value into the database. So what can be the examples for a transaction? Let us suppose if you want to share some amount or transfer some amount from your account to your friend's account, or you want to transfer one of your accounts to different account, and insertion of a new row into the table and updating the existing information. All these are treated as a transaction. So, what is the meaning of acid properties? As we all can see, ACID is an acronym that stands for atomicity, consistency, isolation, and durability. So, what are these properties? These properties collectively define the characteristics that guarantee the reliability of a database transaction. Why the acid properties are needed? Is there really need for acid properties? Yes. The integrity, consistency, and reliability of data are the main objectives of DBMS, as we have discussed in our previous session. To achieve these objectives, the ACID properties form the foundation of transaction management in databases. The key concept of ACID properties and their significance help in maintaining data reliability. The ACID properties are the essential building blocks of any database system, like an e-commerce website, managing the financial records, handling user data, student data in educational institutions, or employees' data in an organization. So coming to the term atomicity. The atomicity says that whenever we want to perform any transaction, then either all of the transactions should be performed or none of them. Let us suppose we want to withdraw an amount of 50 rupees from A's account. Then first we need to know whether that 50 rupees is there in A's account or not. To know whether 50 rupees is available in A's account, we will first perform read operation. Then when we perform read operation, we can get the value of A's account. That is, A is having 100 rupees. Now, we want, what is our transaction? Withdrawing 50 rupees. So, we want to modify the A value. First, we will read the A value 100. From that, we are subtracting 50 rupees. Then, after that, a new value of A will be written to the database. So, what will be the new value? 50. So all these operations should be performed And once the commit is executed, commit command is executed, then the new value of the A will be updated in the database. So the Atomicity says that all the operations should be performed or none of them. Now coming to the consistency. The consistency says that whenever we want to perform any transaction, the data should be consistent before the transaction and after the transaction. That is nothing but the total amount before the transaction is starting and the total amount after the transaction is ending should be the same. Then it achieves the consistent state. Let us say that we want to transfer 50 rupees from A's account to B's account. First we will perform read operation, gives 100, and after that we need to subtract 50 rupees from A. Then we need to modify the new value of A. After that we are reading the value of B. Then we are modifying, adding extra 50 rupees to the B's account, and we are writing the new value of B. So before the transaction, A's value is 100, B's value is 200, total together 300. And after the commit command is executed, the new value of A is 50 and new value of B is 250, total together 300. So the data is same here before and after the transaction. So the data is maintained in a consistent state. Now coming to the isolation. The term isolation means that whenever there are parallel execution of two transactions which are dealing with the same data item, then they should be arranged in such a way that the data item in one transaction should not affect the data item in another transaction. Now if we observe in the example here, we are performing the read operation in transaction 1 as well as in transaction 2. But before the commit of transaction T1, the transaction T2 is reading the value of A. Here, if T1 fails, here in this example T1 is failing and we are performing the rollback operation, which means the data or the operations which we have done will be undone. Here then the transaction 2 results in an inconsistent data. Actually, by rolling back, A value should be 100, but here in transaction 2 it is reading the value as 80. So to maintain the data consistency, we will maintain different levels of isolation, which will be discussed in the later sessions. Next, coming to the durability. Durability says that whenever we perform a commit command, whatever the changes are made with the help of the during the transaction, then they should be permanent in the permanent memory or non-volatile memory. So even there are any system failures or power failures after the commit command, the data should be in a consistent state as shown at the commit statement. So let us have a glimpse of acid properties. Atomicity says that all of them, all of the all of the operations should be performed or none of them. The consistency says that preserving the database invariance, that is nothing but before the transaction and after the transaction, the data should be in the same state. The isolation says that managing the concurrent transactions. If there are parallel transactions, then the data items which are shared should be isolated. The durability says that persistence of committed transactions. That means once the commit command is executed, then the data should be permanent in the database. Thank you.